So continue from yesterday, right? So we have made the table for this arc of, I'm sorry, for the tangent after truncation, right? After truncation. So this curve, this function with the constraint, right? It's from negative pi over 2 to pi over 2. Okay, so that's the green piece. So everything else was chopped off, right? And in this, on this curve, we know it's a 1-to-1, so it has an inverse, right? So we have determined that not only this function has inverse, we already know the domain. Okay, so the angle belongs to, that's the domain for the input, and the range, right? The range is negative infinity to positive infinity, okay? The range is negative infinity to positive infinity. So tangent of that, tangent of any angle from that belongs to negative infinity to positive infinity. So we have done all those groundwork. So that's the picture you see. That's the picture we see in terms of domain and range, right? So how do you see domain and range, right? So once again, if you make a box, right, about the curve in consideration, and you will see the horizontal span is a domain, okay? How wide it is, right? How wide it is from negative pi over 2 to pi over 2. Negative pi over 2 to positive pi over 2, that's the domain. And what's the range? The range is the vertical span, okay? The vertical span here, of course, is indefinite. The box cannot box them in, right? But just the idea, because the box can keep getting higher and higher. And that curve tells you it's going higher and higher, okay? So yesterday we plotted these points. And we also were talking about that this function is not defined at a negative pi over 2, okay? So here, however, right, if we observe, we have done this before, so I'm not going to do this all over again. You just look at, so when the input angle approaches negative pi over 2, okay, let me use a different color, approaches negative pi over 2 from larger than pi over 2, okay? So I'm gonna make that notation visible to you. Look at that picture, okay? Look at that picture, okay? Let me bring this over here on the top. Okay, I'm gonna bring the picture on the top. Well, when we bring it on the top, we don't see the table and the graph side by side. So let me try something else. Okay, let me try something else. Okay, let's do it this way, okay? I will show you the sign just a little bit later, okay? This is a negative pi over 2, and there's a little positive sign on the shoulder. Do you guys see that? Do you guys see that? When the angle, input angle approaches negative pi over 2 from larger than pi over 2. So this is a positive sign on the shoulder. This is a calculus notation. But I think it's rather natural for you to see that being used here, okay? So that's just a little, head start for your calculus class. What does that mean? Negative pi over 2 is right here. This is a negative pi over 2, okay? Approaching negative pi over 2 from larger than pi over 2, meaning that we approach, okay, the input approaches negative 2 from larger than negative pi over 2, okay? All these points coming this way, they're larger than negative pi over 2. That's just nature of number line. The output, you can see is getting smaller and smaller and smaller, okay? So what does this tell us? This tells us that, okay, let me rewrite this. As the angle approaches negative pi over 2, okay, from larger than pi over 2, tangent of these angles approaching negative infinity. Approaches negative infinity, okay? If you want to see detailed work of this, go back to watch the tangent and the tangent curve that we talked about a few, like a week or 2 weeks ago. Now, so this is, you know, you see the function is between negative pi over 2 to pi over 2. So we observe the pattern. We observe the ratio when the angle approaches negative pi over 2 from larger than pi over 2. Okay, so this piece. Now, the next piece. Okay, the next piece we wish to observe. Okay, we wish to observe when the input, okay, when the input is approaching pi over 2 from smaller than pi over 2. Okay, from smaller than pi over 2, right? So this point is pi over 2. This point, you see, the broken red line crosses. That's the vertical asymptote. Okay, that vertical asymptote is the curve that, well, it's a vertical line that a curve will never touch, but it can get infinitely close to it. So when our input approaches positive pi over 2, which is pi over 2 from smaller than pi over 2. Do you guys see that? That's what it means. And what happens to the output? The output is getting higher and higher yet. Okay, so the output, we're talking about the ratio y over x in the definition, right? So that's the picture we get. So in writing, I'm going to write it down right now before we leave this screen, right? This tendency we just observed is that as the angle approaches pi over 2, okay, pi over 2 from smaller than pi over 2, right? You see that if you use words, that's a long description. But I will write down the mathematical notation. Just right now, you just write down the words. And tangent of A will be approaching positive infinity. Positive infinity. Okay, so write that down. Okay, did you get this piece? Okay, after you take this down, because I'm going to delete it and put this on the table. Okay, so that piece we just saw, that tendency we just saw, is that when the angle approaches pi over 2 from smaller than pi over 2, okay? So as this is true, when this is happening, it's a dynamic process. You can imagine this angle is getting closer and closer to pi over 2 from smaller than pi over 2, then tangent A approaches positive infinity. So that's the dynamic process you're going to use in calculus, okay? So with that said and done, we have a complete understanding. We have a complete understanding of this curve, okay? So let's you know, yesterday we talked about, well, I put it on the graph, right? For pi over 4 for this point. What does that mean, right? The making of this curve. When the input is pi over 4, is the orange. How many times we've been using orange? And what's the meaning of that orange piece in this class? The arc length, right? The arc length on the unit circle when we measure the angle from the standard position to the terminal. So this arc length and the purple ratio is the blue divided by red because we're dealing with a tangent ratio. We're dealing with tangent ratio. So now with that understood, let's mark these points together. Let's mark these points together, okay? And that point, okay, is pi over 6. And the purple color with the ratio is the blue divided by red. The blue divided by red, we get √3 over 3. Okay, so once again, the orange and √3 over 3. And that other point is also, right? It's a pi over 3. And the purple is a √3. Okay, and keep going. You look at the table, you look at the graph, and this point, okay, this point is negative pi over 6. And the ratio is a negative √3 over, oh, wrong color, sorry. Purple color. Negative √3 over 3. And that's negative pi over 4, right? And the ratio is -1. And this last point that we plotted is the orange is negative pi over 3, comma, negative √3 in purple. Okay, so this is the tangent curve. This is the tangent curve on that piece. That piece between negative pi over 2 to pi over 2. Domain between negative pi over 2 to pi over 2. Tangent, the range is from negative infinity to positive infinity. This function is 1 to 1, and you see the points. The input are the angles, the output are the ratios. Do you see that consistency? And this orange is consistent with that orange that we talked about in the previous weeks. Okay, it's the same orange that we use for sine, cosine. Does everybody understand? So far, so good. Yes? All right, so now we know this function has the inverse, right? We know this function has the inverse. Have you guys written down on your picture? Yes? Everybody? Did I make any mistake? Okay. All right, so now I'm gonna clean this up and let you look at the table, right? So we have a complete understanding, hopefully, we have a complete understanding about this table, right? What is this table? This table referring to the graph is referring to the table. And not only we have these points in the middle, right? Those special angles. We also have these at the border of that interval, right? Even though we cannot assume the value at the border, negative pi over 2 or pi over 2, but we can get infinitely close to them. One from the larger side and the other one from the smaller side. So these are the things you guys are going to be dealing with in calculus. All right. So here we just touched it a little bit. We just touched it a little bit. With that said and done, okay, so this function has inverse, right? This function has inverse. Okay, so function g, so this is what we refer to, function g. Okay, I'm going to use a, it doesn't matter, right? Tangent a, and a belongs to that interval of negative pi over 2 to pi over 2. Okay, this function is 1-to-1, and it has exactly one inverse, and we call it a G inverse. G inverse. Okay, G inverse, right there. And before we give that a name, we give any name to this G inverse, we already know the domain and range. We already know the domain and range. Okay, so what will be the domain and range of this function? So that once again, so let's get to that part, right? So we have the G with that domain, right, with that picture. Right, with that picture, we have that function right there, right? We have plotting the point, we know everything about it. And this function takes angle, produces ratio, domain and range, etc. Everything we have talked about on this function so far, right? The output is a ratio, of course, it's tangent ratio. The inverse of this function exists. Okay, we're not going to give it a name yet, but we know this function will take ratio as input. Okay, and that G inverse is going to handle that ratio. It produces what? Produces angle. Okay. And these two functions are inverse to each other. What does that mean? What does that mean? One's domain is the other's range. One's domain is the other's range. So what's the domain of the G? What's the domain? What's the range? Are you guys with me? Am I going too slow? I know I'm going very slow. This is the domain and the range. Please complain if I'm too slow. Okay? Because these two functions are inverse to each other. Did you guys say yes? Do you guys mean I'm too slow? Chris? Kelly? You think I am too slow? Okay.
No, that yes was from a while ago.
Okay, sorry about that. I figured. Okay. I'd like to hear some other human voice. All right. So the inverse function, before we even give it a name, we already know the domain is what? One's domain is the other's range. This is the consistency that we said for any pair of functions that are inverse to each other. They have this property forever. We mean forever. We maintain that consistency throughout the mathematics, okay, throughout the mathematics. So we see this again, right? When did we see that before? We saw that many, many times before, right? Didn't we see that many, many times before? From some of the functions we done from number 1 to number 8, and the exponential logarithm, and you know, the sine, the arc sine, arc cosine, arc, now arctangent functions. So we see them over and over again, and they are, and these rules are set up. They're meant to exist for eternity. They meant to exist for eternity. Okay, so now the question is, how would be the picture of arctangent look like, right? So now we can give it a name, right? There are two names for it, arctan or tangent inverse. So these two notations mean the same thing. They have the same domain and range. So how does that picture look like? How does that picture look like, right? That's we want to know. And of course, you can get it on your fingertips. You can get it on your fingertips. Agree with me? But today, I know you can get it on your fingertips, but we're going to construct a table to plot those points. So how are we going to plot that table, right? Plot that table. Now, to make that table, we're going to go back here. We're going to go back here. This is the table we did for G. I'm going to make this table a little bit smaller, okay? Because otherwise it's just too crowded. Too crowded. Okay, so I'm just doing some trimming here. I'm doing some trimming here. We have did all of those algebra yesterday, right? Domain range is all specified, so I'm going to just trim this off, right? So maybe I would do this, right? Domain. You see, I type a lot of things repetitively. Why do you think I do that? Why do you think I do that?
So that it sticks.
That's right. We want you to see it over and over again. I know I'm repeating myself over and over again. This is like my professional, what do you call it? I don't know.
Your style of teaching.
Thank you. But you know that sometimes it can be very exhausting, okay? But I'm happily doing it for you. I hope that sticks. Thank you for that comment. Absolutely. But you really, really have to do it. I cannot emphasize this enough that you must do it yourself. Okay, so let me get the table. So where's my table? Okay, so finally we got this table, right? Yeah. Let me get that table right here. So the table is here. No, not this table, sorry. Okay, this is the table. Okay, this is the table. What we're trying to do, we're gonna create the points. Okay, so we're gonna make another table. Okay, but this table is G inverse. Okay, I want you guys to see how I changed it. Okay, how I changed it. The G inverse table. G inverse table is we're taking, remember the swap we did, right? So it's an arctan. This is X, right? Arctan. So it's no longer the same. Okay, but we know there's a swap, right? From ratio, this time is from ratio to what? From ratio to what? To angle, right? Yes, from ratio to angle. So arctan X, it produces angles. Okay, So the swap, remember the swap we did, right? That swap imply all of these swap we're gonna do, okay? And for all of these angles are no longer the input. They're gonna be what? What are they going to be? They're going to be the output, okay? They are going to be the output. So all of these will have to be changed. All of these will have to be changed. So we're going to change one at a time. So all of these will become what? Take the numbers in the middle, okay? Take the numbers in the middle first. Okay, they are going to be in the output. They're going to be in the output. So what will be the input? What will be the input? Okay, so on this piece, I'm going to remove them, and we're going to come back to it. We're going to come back to it. Okay, I want you guys to have that table side by side. 125%. Let's see if that fonts make it better. Okay, this is better, right? Now the input is a ratio. So the input output swap, that swap action we have known so long ago, it causes so much, you would say, domino effects, isn't it? Can we say that's a domino effect? Input output swapped, right? In reality, this negative root 3 was output, now becomes input. This was output, now it's input. Do you guys see that? That's the effect of swapping. That's the effect of swapping, okay? I'm doing this because I want you to witness the swap. And that's one, of course. Over here. Okay, so what will make that output? ArcTangent, arctan of negative root 3 will make that input, and that's the output. Do you guys see that? Could you finish that the rest of the table on the rest of the 6 with me? Arctan of negative 1 equals to negative pi over 4. Arctan root negative root 3 over 3. I want you guys doing it. Arctan of 0 is 0. And arctan, I didn't do exactly the same way with other functions, but you could have done it this way too. Okay, you could have done it this way too. Arctan of 1 equals to pi over 4. And this also addressed to how we express it algebraically, how we write it down. How do you write it down so your professor recognize them and give you points? That is my point. Okay, that is my point. How do you write them down so your professors will give you the point?
Professor, shouldn't the inputs and outputs be switched?
Yeah, we're switching on this side too. Is that what you meant?
Yeah.
Yes, absolutely. You're ahead of me. Of course, go ahead, do that. Okay, that's the switch. We're not done switching yet. You're absolutely right. I'm glad you get it. Okay, and these are switching too. Okay, I wish I can get that done. Just give instructions and other people do it for me. But in this case, I have to do it myself, one by one. This is the effect of swapping X and Y. Okay, so not only the domain range swap, all of these points, every point on the curve we just did swapped. Input, output, that's the essence of inverse. You guys follow me? That's the essential inverse. So over here is 1. You guys are probably done, right? It just takes me a little longer because I'm talking at the same time. That's the swap. That's a swap. Okay, that's a swap. And then what? And then what? And then what? How about the endpoints? How about near the border? What happened to the border? What happened to the border? Right? That we know it cannot be, we cannot assume infinity, right? You cannot assume negative infinity. Negative infinity is undefined. It's a number we don't know, right? Negative infinity or positive infinity are the numbers we don't know. But what if, right? Because we swapped, right? We swapped. What if the ratio, approaches negative infinity? What if the ratio approaches negative infinity? In that case, tangent of that arctangent of that ratio, arctan ratio is going to approach negative infinity. I'm sorry, negative pi over 2, sorry, negative pi over 2. So it's reversed. Do you guys see that? Negative pi over 2 larger than pi over 2. Whoops. Do you guys see that? Do you see that reversal? This is something you will need in your calculus class. You get it? We swap the input and output. It caused this chain reaction. Okay, it caused all these chain reaction. And now on this side, when the ratio approaches positive infinity, what will be arctan approaching to? Approaches to pi over 2. From smaller than pi over 2. Now you compare these two tables, guys. Please compare these two tables. Everything swapped, right? Everything swapped, yes? Yeah? Everything swapped. Yes? Let us plot the points. Let us plot these points. Let us plot these points. Okay, we're gonna plot these 7 points. Are you ready? This is the effect of swapping. Okay. Right? Is everybody with me so far? So all of these we're doing right now is just swapping XY. Swapping XY. We swapped the domain and range already, right? We swapped the domain and range already, right? We swapped the domain and range already. And this time the domain, the ratio from where? Right? The swapped is from negative infinity to positive infinity. And the angle we're getting is going to be what? The range, right? The range of arctangent is between negative pi over 2 to pi over 2. With that domain and range, if you can refrain from plotting, plugging arctangent in your calculator, can you draw a picture for yourself? Can you draw a box for this description. Input, output. Input, output. Can we draw a description for it? Okay, so I'm going to take this table. Okay, I'm going to take this table. Okay, and I move to the top. And we're going to start to plot. We're going to plot points. So this time we're plotting the arctangent curve. We're plotting the arctangent curve. Before we plot it, okay, remember the boxes I drew earlier? Can you draw a box describing the domain and range? Yeah. From this domain and range information, we know domain is horizontal and the range is vertical. What can you do? What can you draw? You should see a box. You should see a box. Okay. In this box, in this direction goes to negative infinity. In that direction goes to positive infinity. And vertically, the highest is pi over 2, but never touch pi over 2. The lowest is negative pi over 2, but never touch negative pi over 2. You guys follow me? So the box is just like this. So the curve we're expecting to see is going to be between negative pi over 2 to positive pi over 2 because the output is a vertical concept. Okay, it's a vertical. So this box will box your curve inside this box. And of course, it cannot hold it because the domain is from negative infinity to positive infinity. So horizontally, it expands in both directions forever. But vertically, it is bounded. It's bounded vertically. That's what you can tell. That's what you can tell. Okay, so now with that said and done, I can draw some pictures. I can draw the boundary. I'm going to draw the boundary. Okay, the boundary, you can see the output is always between negative pi over 2 to pi over 2. Okay. Oh, wait. So negative 10, positive 10. The boundary is vertically, is between negative pi over 2. So I'm going to make it this way. Okay, approximately. Okay, so let me make some adjustment. Do you guys see what I'm saying? Do you guys hear what I'm saying? When you see domain and range in your mind, there's a box. Horizontal span, vertical span. Okay? Horizontal span, vertical span. That box is described there. We haven't even started plotting points, but you should have that visual in your mind. Okay, so with that said and done, we know our picture is going to be between negative pi over 2. Okay, I'm going to use red. Bounded, broken line, because it doesn't touch. The curve does not touch. So our curve, okay, the curve is going to be between these two boundings. Do you guys see that? That's what it means. Okay, and now we're going to plot some points in between. Are you ready? Everybody should have paper, pencil, okay? And also, I'd like you guys to mark some interesting points here. What'll be this point? What'll be that point? What'll be that point? Can you mark these 2 points? Can you mark these 2 lines? Can you mark these two lines?
No.
Yes, now please. The 2 points over there and the 2 lines. The 2 lines that are bounding the curve we're about to draw. Are you guys there? You're not sleeping, aren't you? So this point should be 0 pi over 2. That point in the bottom is 0 negative pi over 2. Okay, and the line on the top, okay, and the line on the bottom. The line on the top is y equals to pi over 2, the constant function. Remember the first function in the table, basic 1, that's a constant function. The second one is y equals to negative pi over 2. So these are the situations. So our curve are bounded between these 2 lines, extending in both directions indefinitely. Do you guys have a vision? So now if you like to plot, if you like to press your arctangent, but arctangent function in your expensive calculators, you're gonna see your curve is in between. Yes, now you can do that. Of course, I can never really stop you from doing that anytime before, but now we want to see some more insight. Okay, if you could just refrain from doing that, just hold on to it for a little while. We are going to plot the points. Okay, so we're going to plot 1, 2, 3, 4, 5, 6, 7 points. Okay, we're going to plot these points starting from that point. Okay, so I'm plotting these points. Okay, I'm going to make them red. Okay, another point. Okay, you guys do the same, okay? We plot one at a time. And you do the same. Six red points. 6 red points. All right, 6 red points. They're quite small, right? They're quite small. So I'm going to make it a little bit larger. Do you guys see the screen well? This is the arctangent function. This is the arctangent curve. Okay, so let's mark these points. Let's mark these points. Okay. Take this point, for example. Okay, let me do this. I'm going to clean this up. Okay, I'm going to clean this up. I'm going to make this just a little bit larger. Okay, I just feel, I see it more comfortable, okay, to do this. Take, for example, pi of 1 comma pi over 4. The input is ratio, the output is angle. Yeah, input is ratio, output is angle. So when we look at that point, which is here, this is the point. Okay, so this point, input is ratio, the output is pi over 4. What is the meaning? What is the meaning, right? Now, 1, okay, look at the scales. The scales I put up here is different. This whole thing is 10. This is only 1, okay? This is only 1. So do not let the scale fool us, okay? Do not let the scale fool us. So what is the 1? The 1 is going to be the purple. Remember, when did we use the purple? We used the purple last time. When was it? When we were graphing tangent, right? The purple was standing up, but now this time the purple is lying down because it is input. And the output, which is pi over 4, will be the orange color. What does this orange color refer to? Arc length, the arc length. So this is the effect of the swap. The swap of ratio with angle, that's the effect. Does everybody follow me? Yeah? And this is the same for every such point. For every such point. The purple is the tangent ratio, and the orange is the arc length for an angle. For an angle, but this angle has to be between negative pi over 4, negative pi over 2 to pi over 2. So now, do you think we are ready to draw the curve? Arctangent? Arctan. I'm gonna make it red. That's the arctangent curve. Yeah? I'm very certain you're going to use this curve in calculus. Okay. All right. So without further ado, we're making some adjustment to this picture. Okay. So some of the adjustment need to be, I just removed it. All right. So this is the arctangent curve. So let's mark the points. Okay. We're going to mark the points because the next thing we're going to do, we're going to bring the two pictures together. We're going to bring the two pictures together. But bringing the picture together is really, really not easy because no software will graph the tangent curve in that interval, okay? So as I explained earlier, it's just, I have to do it manually. But anyway, so let's, in order to understand this, so let's mark each one of these points on the arctangent, okay, with the color toned, properly arranged. Okay, the purple number, okay, the purple number here is √3. That's the input is ratio, and the output is orange, pi over 3. Okay, and the next one, this is 1. The angle is pi over 4, referring to the arc length or the angle. Okay. The next one is √3. The ratio. The output is pi over 6. Keep going. This point is negative √3 over 3. And the angle is negative pi over 6. Whoops. Negative pi over 6, orange color. Okay. Negative pi over 6. That's this point. The next one is -1, comma, negative, change color. Negative pi over 4. Okay, The next one right here. Purple, which is a negative √3. And the orange color is a negative pi/3. Okay, now how about the border? How about the border, right? This is very useful for you. When x approaching negative infinity, okay? When x approaches negative infinity, okay, the horizontal, okay, approaches negative infinity. What happened to the arctangent curve? The arctangent curve will get to negative pi/2 from smaller than negative from larger than negative pi/2 as close as possible. You guys see that? Getting infinitely close to negative pi/2 from larger than negative pi/2, okay? It's very tricky. When I speak these words, I have to be very careful. I don't want to say any bad word, any wrong words. Okay, so how do we express that? When x is approaching, so this corner, it means when the ratio, okay, when the ratio approaches negative infinity, so when x, that ratio approaches negative infinity, arctangent approaches what? Look at that, it's so ugly. I can't bear that. I need to rewrite it. Forgive me. This is unbearably ugly. Okay. Arctan of x approaches what? What does it approach to? It approaches to negative pi/2 from larger than negative pi/2. Because these are the negative side. Do you guys see that? Right? So this is a negative pi/2. Any number above it are larger than negative pi/2. This is very tricky. You have to really understand the graph. You understand what you're doing. And I have made no mistake so far, I think. I don't see any mistake right now. And Farouz, you got to keep your eyes on my mistakes. Yeah?
I'm trying.
You're trying. Thank you. Okay, so that's on the boundary. Very likely you're going to use this, especially the other side. Let's see what's happening on the other side. When x is approaching positive infinity, what happens? What happens? The angle will approach pi/2 from smaller than pi/2. Actually, I should change this color to orange. Okay, sorry. I should change this color to orange. Okay, that'll be fitting for the arc length. Okay, so as x approaching positive infinity, so this piece, right, and the angle will be approaching pi/2 from smaller than pi/2. So how do we express that mathematically? When the ratio, okay, ratio, I'm using purple. Okay, when the ratio approaches positive infinity, okay, arctan produces angles. And that approach is what? What does that approach? The approach is pi over 2. Remember that the boundary from above is pi over 2. Pi over 2. I'm writing pi over 2 in orange color because that's pi over 2. Let me make it thicker. Okay, pi over 2. Okay, from smaller than pi over 2, because we're from bottom up, right? From smaller than pi over 2, and the notation is we put a little negative sign on the shoulder. This is I think the most important features about ArcTangent. And I am 99.9% certain you will encounter this function in calculus. Okay, any questions so far? Look at that swapping effect, right? That swapping effect, we spent, how much time did we spend? Like 30 minutes on it? The swapping effect, the domino effect was swapping, right? The implication of swapping. Okay, did everybody write it down? Do you have any questions? Do you have any questions? So ArcTangent can take any ratio as input, right? ArcTangent can take any ratio as input. So ArcTangent, when you see ArcTangent followed by a number, it doesn't matter. It can be any number. That's what domain means. ArcTangent can be any, can take any input. But the output is always between negative pi over 2 to pi over 2 exclusive. Exclusive. Got it? And now you see these points, you see the pictures, and you see the implications. Are we good so far? Did you guys write it down? I'm going to write these down. I think we already did. I think we already did on the table, right? Those will be better looking. And I really don't like these writings I have I did for myself. I think in this aspect, I'm somewhat a perfectionist and I just cannot. But in order to keep everything together, that's what I can do. Okay, that's what I can do. Does everybody get it? So could I clean up and go to the next stage? Are you guys there?
We're here.
Okay.
I'm here.
That's very reassuring. Okay. All right. Do you see a lot of, have we seen a lot of consistency? A lot, right? A lot of consistency. A lot of consistency. Okay. So with that said and done, and you can see tangent function on that piece is increasing. Its inverse function is also increasing, right? So we have done these points. We really have a feel for these two functions as inverse function to this, as a pair of inverse function. But now what if we compose these two functions together, right? Composition of them. Well, that's go back to that property we talk about, right? Any pair of functions that are inverse to each other, and we have that very special properties. So now we're gonna get to that point, okay? And then we'll be able to handle trick 7a, okay? And we're doing trick 7a to prepare for trick 7-8. You guys follow me? Did you guys take a look at what trick 7-8 is telling us to do? That's where we're heading. Okay, that's where we're heading. All right, so I'm going to clean this up finally. Okay, we have these forms, the mathematical correct forms, right? 2 pi over 2, smaller than pi over 2, we're good, we're good. Okay, so with that said and done, when we bring these two curves together, guess what? And the software I can use produces a mess, okay? So I did some PS. I did some PS. So this is what I get. Okay, so let's bring our ArcTangent here. Okay, let's bring our ArcTangent here. Wait. Okay, over here. So now they're side by side, right? They're side by side. Are we good? So these two curves are together. These two curves are together. They're inverse function to each other. They're inverse function to each other. Oh, this is just so awkward. But anyway, I don't know what I can do. But let's just move forward, right? But when I bring these two curves together, it creates a holy mess like this. That's not what I wanted, but no software can do it, right? Do it correctly for me. So as a result, I'm using a little bit PS. When we bring these two functions together, we still see that beautiful feature, okay? These two functions that are inverse to each other, they are symmetrical with respect to that y equals to x, right? That line. And we have a vertical asymptote for tangent and horizontal asymptote for arctangent. All right? And right here, wait. That's what happens when we bring these things together. Okay, just hold on just 1 second. Okay, just give me a little bit time to bring them together. %. Okay, so they're next to each other. They're next to each other. So this is the table we did. We summarized the domain, range, all those other important features, right? And when we bring these two together, we still see the same consistent symmetry along the line of y equals to x. Along the line of y equals to x. Do you guys see better this way? Okay, we plotted the points on the green, we plotted the points on the red. So when we bring these two, this is the pair that's inverse to each other. That's inverse to each other. But the green piece is usually not used unless otherwise specified. So the tangent function, just like sine, cosine, right? Whenever we talk about the tangent function, what function do we refer to? We refer to what we say, A cannot be odd number multiples of pi over 2. This is the function we refer to, always, unless otherwise specified. Okay, we'll show you. The range, of course, is from negative infinity, right? So that's a domain. And that's the range. Okay, so most of the time, most of the time, unless otherwise specified. The function we talk about when tangent or arctangent are mentioned, we always refer to, just like with the other functions we talk about, we always refer to this function and that function, and this function is not specifically mentioned. It's mentioned as otherwise specified by restraining, but this is specified, the domain is between negative pi over 2 to pi over 2. You guys follow me? That's why it's when you try to draw the graph, right? If we try to draw the graph of these functions, guess what do you get, right? Okay, guess what you get? If you want to draw tangent and arctangent together, right? I just passed that picture, right? I told you that was a holy mess. This guy. This will be the graph you get by the software I can have my hands on. I can have, so I have to do the chop, PS to get, because when tangent is mentioned, this is the tangent we mentioned. We imply to all the greens. And when we talk about arctangent, and this is one red piece. Okay, so now with that said and done, I'm going to put this away. For this pair, okay, okay, which has that nice properties, right? One's domain, the other's range. With these two functions, right, we have done separately marking those points. We also have another property, which we're going to get to, is that f, okay, f of x, let me write it this way, f and f inverse are inverse to each other. Okay, to each other. Okay, with all the description we have mentioned, one's domain, the other's range. Okay, both are 1-to-1, so on and so forth. And we know that f of f inverse of x, remember that property? For x, x should be where? In the domain of what? Of f inverse. So this property will never change, okay? This property will never change. And the next one is f inverse of f of x. And that will be for the x in the domain of f, right? Remember this property we used over and over again for all the pairs we've done so far, right? And these apply to the G and G inverse here. So what is our G? What is our inverse G? Okay, so I'm going to bring this back up with us. Sorry, let me just get that piece so I don't have to write them down. So this piece, okay, I'm going to extract. This piece I'm extracting. This piece I'm abstract, you know, I'm going to, you know, extracting this piece, okay? That piece, right? Now, for this pair we're working with G, it works for G. So all you have to do is just change to G. G inverse, right? G inverse, just change that. Do you guys follow me? And the domain of G inverse, the domain of G. No difference, right? Do you guys see that? And now it's time to put those specialty in place. G, what is G? G is tangent. G inverse, what is G inverse? Arctangent. And this X need to be from where? From where? From the domain of G inverse. What the domain of G inverse is from negative infinity to positive infinity. Boom. You look at the third row of the first table in trig 7a. And that is one of them. That's one of them. And the other one, G inverse, is arctan, and G is the tan, otherwise specified. Otherwise specified. How is it otherwise specified? X is in the domain of G. The domain of G is this guy. This is how we do otherwise specified. So that turned into the two properties you saw on the third row of the first table in trig 7a. Do you see that? So this is how we otherwise specify it, right? Tangent applied to X if X is within this interval. For example, this statement will be wrong. Will be wrong. Okay, just kidding. Right? How is it wrong? Because this is not always true. It is true conditionally. What is the condition? When X is between negative pi over 2 to pi over 2. Exclusive. You follow me? So this statement is wrong and this statement is true. Do you follow me, you guys? So now let's see how we apply it. Okay, let's look at trig 7a that involve these features. Okay? Are we good? Are you tired? All right.
Good.
You're good. I'm glad. Thank you for holding your attention for so long. This is lots of stuff, isn't it? Okay, so let's look at some arctangent, tangent, arctangent. Okay. 27. Trig 7a. Okay, number 27. Number 27 says tangent, arctangent of 3/2. What would that be equal to? If you understand the process, this first statement, okay, even though we have this 4, but this statement is unconditional. Are you guys with me? This statement actually is conditional because it's true for any real number. That's mean unconditional. This statement is conditional. You guys see that? That's a different way to see it. Unconditional, so this is always true. So if I write it down like this, without specifying that, it would be true. You follow me? Yeah? Because it's true for any real number. Of course, whether you have this specification or not, it really doesn't matter. This is the specification that's dispensable. Do you follow me? Because it's true always. So no matter what's the ratio. So what will be the answer here? What will be the answer here? Compare. What will be the answer for this one? Yeah.
3/2.
That's right. That's the easy one, isn't it? If you understand the property, okay? So you could apply, so this would apply. But I also understand this piece is very difficult. Sometimes it's, first of all, I don't want you to rely on memory. That's why we have gone through this process, right? But what if you're not sure? Because people tend, including myself, right? We tend to debate between these two when we don't see it, when we kind of somewhat forget. What would you do? Okay, suppose that 2 semesters later, right? In the spring, you take Calc 1, in the fall, you take Calc 2. You might not be quite remember this process. What do you do? What do you do then? What do you resort to? What you can resort to is you understand that arctangent takes ratio as input, tangent takes angle as input. Okay? So in that regard, then you can resort to ARD. You can resort to ARD. In fact, these techniques is often used in calculus 2. Okay, so your teacher may cover that, you may cover it then, if you're lucky, and he or she has the time. And oftentimes we don't know how thorough or how much time they have, right? So in that case, you can always resort to ARD. How does it work? ARD? Okay, you also have to be clear about the domain range, okay? So I'm gonna do a little bit think out aloud for you. So you see that how the role of, domain and range, okay? Think out aloud. When you think out aloud, if a calculator is permitted, right? You can quickly draw the arctangent curve, arctan curve, right? Arctan curve is bounded above and below, right? Between -π/2 to π/2, right? You guys with me? I'm not against technology. You can use this technology, but you have to know how to read it. You know that arctangent is between -π/2 to +π/2. So the range between -π/2 to +π/2 is this inequality. So this quantity you're getting, yes, you're getting a theta, right? For 3/2, you're getting an angle, but this angle is going to be between -π/2 to π/2 in particular, because this is a positive ratio. Okay, so your angle actually between 0 to π/2. Okay, we addressed a little bit about arctangent earlier on, is that when we deal with arctangent, the angle we get, what are they? Quadrant 2 or quadrant 3 are no flight zone. We mentioned that before, right? Okay, because the range is between -π/2 to π/2. With that said, when you take tangent, right? If you know this angle is between -π/2 to π/2, when you take that tangent, you're taking a tangent angle that's either terminate in the first quadrant or the fourth quadrant. For 3/2, because it's a positive ratio, you are certain where will be the terminal? The terminal is going to be somewhere here. Okay? All right? And so you know the D. So for arctangent, you know the D, right? You know the D. D is definition, right? So ARD, we know the D. I want you guys to see that with a clear eye that what you have and what to be found, right? And we're looking for angle, but this angle in this case has to be where? Has to be between negative pi over 2 to pi over 2. Right, so all these notations, it's just for convenience. If you understand them, it's gonna help you to express. Okay, so we're looking for the A, we know the D, we know the D ratio is 3/2. And from analysis, we know that terminal is gonna be in the first quadrant because it's a positive ratio, And it's 3/2, the definition of a tangent is opposite over adjacent sides. So you can even draw that triangle. Hold on. Okay. You can even draw that triangle, the opposite side. Whoops. I should use blue. Okay. Why do I use blue? Because the opposite side, we use a blue, right? It's relating to the blue on the unit circle. And the red, tangent ratio is a blue over red, right? Blue over red. So now you have this is 3. Oh gosh. Okay, the blue is a 3. The red, refer to the red. Are you guys with me? You need to know how to do this in Calc 2, okay? So once we've done that, we have the terminal, right? Now we have the angle. We know the angle is where? The angle is in the first quadrant, terminate in the first quadrant. So tangent of theta is, of course, going to be 3/2 again, right? So it's obvious you're going to have 3/2. Are you guys with me? So even if you don't know this, special, identity, you can still figure out from ARD, DRA. Got it? Yes? Did I make myself clear, or am I too slow or too fast, or?
No, you're very clear.
Okay, thank you. All right, so let's move forward. So let's try a couple exercises from your side, okay? So these analysis, these technique of analysis, you can see I do it at around the definition, okay? Really, in trigonometry, the one singular 3 pieces you need to know is ARD, okay? All the question you encounter is either A to D or D to A, all right? So let's pick a couple of questions for you to work with, and maybe we can do some breakout rooms. We have only 10 minutes left. Oh gosh, we have only 10 minutes left. Okay, so for the 10 minutes left, I think we're just gonna do this together. Okay, we're gonna just do this together. How about number 33? Okay, number 33. Number 33. We have a arctan and tan, 2 pi over 3. 2 pi over 3. Can we apply either one of these 2 properties we have just learned? Can we? Can we apply either one? We certainly cannot apply the first one, right? The first one doesn't match. How about the second one? No, because 2 pi over 3 is not between negative pi over 2 to pi over 2. So I'm just going to put this comment here. Okay, I'm just going to put this comment here. Okay. When you show work, you really don't, you don't need to, okay? Does not apply. Does not apply. Oh, sorry, wait. Am I doing the wrong thing? Absolutely. I think I did the wrong thing. Not this one, not this one. Sorry. It's the latter one. Okay. No, sorry. This applies. Wait, does not apply. I'm tired. I'm tired. Sorry. Does not apply. Okay. Because 2 pi over 3 is outside that interval, outside interval specified. Okay. So now, what can we do? We can only do it from inside out, or you can use it from definition, you know, just measure the angle. The first you do the inside, so you will get, what do we get? Tangent 2 pi over 3, you have a terminal, right? That terminal, if you have that unit circle with you, that will be a bit easier. Where's my unit circle? Come on, come back. Where's my unit circle? There. Right? If you have your unit circle, you measure ARD to do that piece. 2 pi over 3 right here, right? You have a blue number, you have a red number, and the tangent ratio is red divided into the blue, right? So what do we get? Blue over red, what do we get?
Negative root 3.
Perfect, okay? Negative root 3, right? Negative root 3. So for negative root 3, what will be the angle? Your answer has to be between negative pi over 2 to pi over 2, right? So there's another place that will also give us the same thing, the same ratio. What would that be? Negative root 2, negative half root 3 over 2. Is there another place? It's over here, right? Yes? It will give us the same ratio, right? Do you follow me? It gives us the same ratio of negative root 3. Do you see that? But which one will have the terminal in the range of arctangent? Remember, this is no flight zone. So our angle can only be what? Our angle can only be what? Our angle can only be measured in a certain way, which is negative pi over 3. You follow me? Okay, they're all very similar ideas. So the answer here is negative pi over 3. I will have you guys continue to do the exercise and also work on ArcTangent. The idea is very similar, okay? I might mention ArcTangent a little bit tomorrow, but I hope I will not have to spend too much time on it, okay? Because your focus usually is sine, cosine, tangent, arctangent, okay? These three pairs, okay? So to summarize, I do have something to summarize for you. When we summarize the, so for example, starting from this property, right? I wish to give you the interval, the inequality form of it, okay? Which is negative pi over 2 to pi over 2. So the other description I wish to give you, especially because you guys are just not very familiar with inequalities. Okay, so that's one place I want to add just a little bit nuance. So you guys are familiar with it, okay? The next one is going back to the summary. Okay? The description of the range, The description of the range can also be written, okay, in these forms. Number one, it's between these two, okay? Or arctangent absolute value less than pi over 2. A lot of these will show up on your exams, okay? I will test you guys to know how to use these inequalities. Okay, so that's for arctangent in terms of the inequalities, to describe their range, okay? Which convey the same message, Okay, what is that same message? The same message is that the arctangent, which is the red piece, is bounded between negative pi over 2 to pi over 2. So that convey the same message. Very, very important. If you understand this, and you will know when we approach, right? When you do the limit, when you approach negative pi over 2 from larger than negative pi over 2, or you approach pi over 2 from smaller than pi over 2. And these are the calculus concepts, okay? So, but I introduced it here. I want you guys to see how natural those notations are introduced, okay? And without those notations, you just have to use many more words to describe that, okay? So far, so good?
Professor?
Yes.
Comment, if I can.
Please.
I guess you're trying to tell us the style of memorization is not going to work anymore. This class 3 calculus is changed the style of learning from memorization to understanding, and we have enough time, 1 whole semester. When you go to the calculus, then with this method of understanding, life comes easy when you are on those classes.
That's what I hope for. Okay, but I will do the best when I'm teaching. The reason I'm saying that, after the midterm exam, I'll be gone for medical leave. So you will have a substitute. I was thinking to announce this later, but for your information, all of my recordings will still be available. I hope that the new teacher will take that. And yeah, you will get all the recordings, but you can, because I wish to maintain some kind of consistency in your learning. So you're welcome to watch the recording, but the new teacher will teach it in his or her way. And I hope whatever I have done, it lays a good foundation so you can work with anybody who's teaching math in the future.
Professor, is it
going to be a new perspective? Yes.
Is it going to be for the rest of semester, or is it?
It's going to be for the rest of the semester, unfortunately.
Unfortunately, yes.
Yeah, unfortunately. I have a big surgery coming up, so I will not be able to resume teaching until the end of the semester.
Sorry to hear that.
Thank you. I think I'll be fine, but I'm a little scared too.
One more question, Professor. Is that your choice? You can choose your substitute teacher, or it is the department does that? Because you know your style of teaching, you know who is going to be the best substitute teacher.
I don't know how many people will volunteer to sub for me. And I certainly would talk to the teacher about where I'm at, but I'm certainly not the kind of people who tell other people what to do. And the other teacher will do what he or she feels most comfortable. But I'm telling you guys this with much regret, because I feel you guys are my children, and I don't want to leave you guys unattended. But on the other hand, for my medical reason, I have to do what is necessary to to get the treatment. But anyway.
Will this change anything from like the syllabus as far as how the class is graded?
No, it should not be. It should not be. I will talk to the sub, but that's going to happen on the 27th. That will be after the midterm exam. Okay, I know that's shocking for you to know that, but I think I want you guys to be somewhat prepared. And from my perspective, I will be I'll be while I'm teaching, I try to give you as much as possible in my style, but you should be ready to learn in any style, right? I think that's the fortunate and unfortunate nature for being a student. And I wish I don't have to do this, but I have to do this.
So if we learn it, we can, if we learn it, not memorize it, then we are going to be capable of following any style of teaching because
exactly. That's what I'm hoping for.
Yes, ma'am.
And of course, I knew this a couple of weeks ago already. I was just debating whether I would do the surgery. But that's why I'm working so hard to get you guys this nailed in you and have the recording for you. So because I know not every teacher will do this. And because they don't have time or for a variety of reasons, they may not do this. Of course, I don't think I'm indispensable. I don't believe anybody's indispensable, but I'm just trying to do the best I can to help you to help you guys in the long run.
So we still have 2 weeks to learn from your, lecture.
Right, if that helps you, okay?
Definitely.
All
Thank you. Thank you letting us.
Yes, of course. I will see you guys on Thursday, which is tomorrow.
Yes, ma'am.
Thank you very much.
Thank you.
Thank you, guys.
Professor.
Yes.
So even though a substitute will come, will the way the quizzes are given change or no?
For that part, I actually cannot speak for that substitute. Okay, because all of the quizzes I give you guys are prepared by myself. I work out my lectures and I prepare the quizzes. And as for the substitute, I wish you guys understand. We are peers, and I'm not entitled to tell him or her what to do, which I don't feel comfortable to do either, right? But I personally feel I have given you, from my perspective, my best. So hope that will carry you for some time to come. But I'm still around. I'm still here. Okay.
Okay. Thank you, Professor.
Of course. So while we can, I still want to enjoy you guys, and I'll see you guys tomorrow.
Thanks for the lecture, Professor.
Of course. I enjoy it tremendously. Thank you for coming.